Welcome back to the course. We'll be hopping into the basics of the GDScript language and learning some of the fundamentals we need to start writing our first lines of code. Now, this won't be a full in-depth explanation of GDScript. That would take a very long time and honestly could be a bit overwhelming. But let's actually just get started. Let's load up our Godot and we're going to create a new project. With that open, let's give it a quick name. I'm going to name it test GDScript. I'm going to create a new folder, that way it's all kind of organized for us. I'm going to leave it on forward plus. I'm not going to use any version control because it's not really necessary for this. Then I'm going to hit create and edit. Now we're in our editor, we're going to want to create a quick little test scene that we can actually add a script to so we can kind of get our code running and test it out a little bit. To do that, what I'm going to do is go to this 2D scene button under create root node. I'm going to name this test scene. I'm going to hit Control S to save, and then I'm going to save it in the predefined or default directory that it wants me to save into. And now what we can do is go to, if we click on the root node that we've got here, so the test scene node, and we go and click on this little script icon with this little green plus, and we click attach, it will give us a, this will basically attach a node to the script. So this is going to create a new script for us. Now we can name it anything we want to. I'm just going to leave it as the default test_scene. I'm going to hit create, and it should take you straight into the script view here. If it doesn't take you to the script view and you're still here, if you go to the top and you hit script, it'll take you into the script view. Now that we're here, let's look at the interface so we can get through that and then move into some coding. Now you'll notice there are two new panels here that popped up, the filter and filter. So you've got the filter scripts and filter methods panels. This one will basically show you all of the scripts that you currently have opened, and you'll be able to switch between them. So the more scripts you have, the more this will be populated. And this will be able to filter between different methods within predefined scripts. In this case, it will be filtering through methods on the test_scene script. Now, one thing that we're going to be going through in here are a lot of the data types that we plan on using through the course. So just make sure to take notes in the style of teaching as we go. And a very quick thing to keep in mind is we won't be going across every data type or covering every data type, just the ones that you'll be seeing the most of. So to start this out, let's first look at int or integers and how we declare variables. So to declare a variable in GDScript, all we have to do is write var. Var is a variable declaration, so var stands for variable. Then we give it a name. I'm going to give this the name of myInt. So there are a few different kind of naming types in this, or conventions or casing conventions. You've got this style with double capitals. You've got the one that I actually usually prefer to use, which will be adding an underscore between the words. It just makes it a little bit easier to see, and that tends to be the method that Godot will kind of automatically go to as well. So we have a var, and it's called myInt. Now what we can do is go equals, and then set it to a number. Why are we setting it to a number? Well, integers are whole numbers, so they are any number that is a whole number going from 1 to, I think it's actually like negative 32 million something to positive 32 million something. I could be a little bit wrong there. It might be larger, it might be smaller, but they're really big numbers basically. But as long as they are whole numbers, i.e. no decimal places. So that's kind of like integers. Now, where would we use integers? Usually I use integers for things like health bars or damage numbers, for instance, where I want to keep that whole value. That way it's kind of a little bit easier to calculate. With int finished, let's move into the next data type, which will be floats. So we'll do the same thing. We'll do var. We'll call it my_float. And we'll set this equal to, let's go 10.5. So floats are floating point numbers. So these are the ones with the decimal place. So you can do pretty much nearly as many as you want to get like a very, very accurate decimal place. Usually you'll see one decimal place like so, where it'll be like 10.5, and that's it. I tend to use these a lot for movement related code, i.e. what do I want my character's movement speed to be? What do I want gravity to feel like? How do I want things to move at certain speeds? Things that can kind of travel between 0 and 1, so to speak. So count up from 0 to 1, so I can get percentages and a bunch of other different things. The next one we'll move into will be strings. So we'll do var my_string, and we'll set this equal to, now it's very important with strings that you add your double quotes, and then you put something inside of those. So I'm going to call this my string equals my space string. These are basically a string of characters or a sentence, pretty much like if you want to name something. So if I want to give something a specific name, say I wanted to, let's change my string to my name, and then here I'd put in my name, and then wrap that in quotes. This is how I would name things. So I would store this as a string variable like so. So this way it would be coffee crow. This is my name. That way anything that needs to read or be placed as text on the screen, I can store them like this. So I'm going to rename this to my string, leave it like that. The next variable we're going to go into is the vectors. So var my underscore vector2. Now, what is a vector2? Well, a vector2 is, let me actually just show you how to kind of create them. So to create a vector2, you start with the word vector2. The capitalization on the word vector is very important. And then you open your parentheses like so. So your curly braces, just parentheses, I guess. And then you have to input a x and y value. So in this case, we'll do 10, and then we'll separate that with a comma, and then we'll do 10 again. Now you'll see here that the kind of IntelliSense, the little note that it's giving us is vector2 has to equal float float. It doesn't need to be float float, but it's usually a good idea to actually give it a float and a float, because vectors are primarily used for positions, locations, and movement. You tend to see a lot of vector2 math when it comes to movement specifically. You'll do times one vector by another vector to get a decent location or a specific location, and then you'll apply other math to get that to move towards that location. So vectors are quite useful in that sense. Let's move into the next variable, which will be an array. So we'll go my underscore array. We'll set that equal to. Now, to create an array, it's very simple. You just open square brackets, and this is an array. Arrays contain a lot of different data types inside of them. Usually when you're setting up an array, or at least how I tend to do it, is when I set up an array, it will contain one specific data type and multiple values for it. We usually tend to use arrays for storing, let's think of a wave survival game, right? You have all of these enemies, and you want to make sure that when there are no enemies left, the game ends. Or, more specifically, and another important one for optimization reasons, you want to make sure that the enemy count can never go above a certain number. So to do that, you can store all of these enemies inside of an array, and then you can check if that array size is going over a certain amount, or if it's hit 0. If it's going over a certain amount, stop the code from running. If it is under a certain amount, or if it's at 0, then wave complete. And you can also do a bunch of different things with the variables inside of the arrays. So you can access the individual monster or character or whatever at, and I'm going to do this real quick to go 0, 1, 2, 3, 4, 5. Say I wanted to access something at position 1 here, which, by the way, a quick thing about arrays, they start counting from 0. That's why I've kind of named them like this. So this is position quote unquote 1, but it will count from 0. So this will be position 0, 1, 2, 3, 4, 5. Just one of those things to keep in mind, because you might go, oh, this is position 1, 2, 3, 4, 5, 6. That's not entirely how it kind of works. Yes, back to my original example. Say you wanted to access the data for the character or monster at value 1. So here, in position 1, what would it be? Or what would I be able to do with that? Well, I would be able to access its specific data structure or variable or whatever's stored within inside that character, and I'd be able to use and call certain things based off of that. We'd usually go through that with things called for loops. That way I can do it for every single thing in the array. Now, that will be a really rough and basic explanation of arrays. That's kind of how we use them, and we will be using them quite frequently, and I will get around to explaining them in more detail as we go. So moving on to our next variable, we have my personal favorite variable, which is let's call this my underscore dict, or let's just call it dictionary. There we go. So a dictionary is honestly amazing. Think of an array, but you can store things in a lot more complex ways and kind of make it very, very, very formatted in certain ways. This is what I usually use. Like I use dictionaries for creating things like save data and storing massive tables of certain things. Say I wanted to have enemies with certain types and certain like stats, I would store the enemy and its type in a dictionary, and then I'd be able to access its stats because that would also be stored in a dictionary under its own unique thing, which we will also get into quite heavily. Now, this is how you would set up a dictionary. To actually start filling it out, you need to give it something called a key and a value pair. So in this case, we'll give it a key. I'm going to just give it a string-based key for now. So this will be called key. And then we need to separate it with a colon. And then we give it a value. I'm going to set the value to 12. Now, what happens with this is when you want to access the dictionary or access the specific key and its value, you then access it by going my underscore dictionary. This is going to throw a bit of a fit at me, so ignore this for a second. So in here, we would go my underscore dictionary, and then we would access it by either opening up square brackets. We could use different methods inside of actual dictionaries themselves to get certain values. There's a lot of ways of accessing and using dictionaries, and we will cover all of those when we get to some of the important systems that we need to use for them. Now, that is the basic variables that we will be putting to use. You will see these used quite a lot as we go. And with a kind of very basic understanding, we can now kind of move into things like functions and how to set those up. But I will say, as I said at kind of the start of this, there are many data types. We'll be making use of a lot of different data types, not just these. These are just the ones that you'll primarily see, and the others we will end up kind of walking and talking through as we get to them. And of course, if you want a full kind of in-depth guide into GDScript, if it gets asked for enough, I can probably plan out an entire like mini series or something on that. It would be, I think that would be kind of fun. Anyway, let's move into functions and how to set those up in general. And then we'll move into something very specific that I like to personally do when creating variables and functions. So first, to create a function, you need to write the word func or func for function. That lets the kind of engine and GDScript know that we are creating a function. Then we name our function. I'm going to call this my underscore function. And then I'm going to open a set of parentheses. That creates a function. At the very end of this, I'm going to end it off, or cap it off, so to speak, with a colon. And then I'm going to press enter. And you'll notice that it's now moved or indented my cursor in one to let us know that we are now within a function. Functions are extremely useful. There are a lot of really simple things that I feel like don't entirely get taught enough when it comes to functions that should be kind of shown immediately rather than allowing people to build on bad habits. And one of the things we'll get into with some of our prototyping is to make sure we kind of get out of some like certain bad habits very quickly. So this is a function. Inside of a function, we can kind of create code and run code. Say I wanted to go my underscore int, let's go times. So we'll use the star for times. And then I will times it by my underscore float. That's a function. What that's going to do is take the numbers from my int and my float, times them together. We could even go one further and go var my underscore equation. Is that how you spell equation? I have no idea. Set that equal to this. And then we can use what's known as a print statement. So print. This is a built-in function. So it's another version of a function. And then we're going to print my equation. And then hit Control S and save. Now, to show you how this kind of functions, I'm going to open up what's known as a predefined function within Godot. That is the ready method or ready function. To do that, we're going to write func underscore ready, and then we'll enter that. And inside that, I'm just going to call my function by typing in my function or my underscore function and then the parentheses. This lets it know it wants to call a function specifically. Now I'm going to hit Control S and save. And I'm going to hit the run current scene button. And you'll see down here in the output, it printed a number out for us, 105. And that is because my equation is equal to my int times my float, and that comes out to 105, i.e. 10 times 10.5 is 105. So that's kind of the basic use of functions. We will be using functions for a lot of different things. Pretty much everything that can be put inside of a function will be put inside of its own unique function. It's one of the habits that I found myself needing to get into is functions should be designed for specific things. They should do their own specific things, and when they're done with that, they should lead into either another function or get called inside of another function, or kind of XYZ type of deal. And as I said, we'll get through that and get into that. Now, with this done, there are some really simple, really little things that I kind of want to get into about how I tend to make variables. So let's first talk about exporting variables and onReady variables. Now, an exported variable is a variable that you can edit outside of the script. So to do that, we'll use the @ sign, so @ and then we'll use export. And then we'll type our variable, so var, let's do my_exported_variable. We'll set this equal to, let's go 40. So we'll set it equal to an integer of 40. Then we'll hit Control S and save. And now if I click on test scene, you'll see up here, the rest of these variables aren't actually in the editor, but the exported one is. And you'll see how it's actually taken the naming convention here. It's changed, so every single word here that is separated by a underscore is now capitalized. And we can edit this from inside the editor like so. So I could change this to 20. You'll notice that doesn't get reflected in the script, and that is because 40 is set as the default value. So if I click this refresh button, it will change it back to its default value. So that's exported variables. We'll be making use of those in quite a few different places. That way we can get kind of ease of access when it comes to editing a lot of our kind of character-specific variables. Like say we want to mess around with our movement speed and try and get it right in our prototype. Like we design an entire movement thing out in our prototype. We now want to just modify and mess around with these speeds to make sure it feels good for what we kind of want in the future kind of primary project. We can just export that out and we can mess around with it and get it to function right. So that's exported variables. You can do this with any type of variable. So if I wanted to, I could go down into, let's say, my vector. I'll add export in front of it. I will then hit test scene, and you'll see the vector has been exported with its X and Y coordinates. You can do this with dictionaries as well, as far as I'm aware. Yep, you can. You get the dictionary size, then you get the key, its current value. You can kind of export pretty much any variable you want to export, including arrays. So with these set, let's move into onReady variables. So to do that, you do @onReady. That's it. And then you create the variable again. So you go var. Specifically, onReady variables tend to be used for certain things. So let's just call this my_onReady_variable. We'll set this equal to 60. Now, onReady variables, you will not see kind of used as, or at least you will not see me kind of set them like this. I use onReady variables when I need to get a specific node that is part of our scene into the script so I can modify it and kind of mess around with it with code. That's usually the time that I will use onReady variables. Let's hit Control S to save real quick. Get rid of the star. Always a good idea to get into a habit of saving. So onReady variables, as I said, we will get into more as we kind of start building out larger scenes and needing to kind of access other nodes within the scene inside the script. So that's our exports, our onReady's, basic variables, functions sorted. Let's go down to more at the very top here. I want to talk about two specific ways I tend to kind of set up my variables. And actually we can use the exports here and normal variables. So for exports, what I will usually do is I will do what's known as typesetting. And then for onReady's, I will do what's known as typecasting. So typesetting for, say, my exported variable, which is a integer, I will add a colon just before the equal sign and then set it equal to an int. So I will go colon int equals 40. Now, why do I do this? Technically, the performance benefit that this gives is only really truly visible in a very, very large project. But the readability, however, is much more of an important thing for me. When I'm designing or teaching, I like to make sure the code is extremely readable. Usually I will zoom in a little bit to make sure it's a nice kind of big script. It does not like it when I zoom in. If you want to zoom in, you can use Control and then mouse wheel in or out. Yes, I like to make sure that you can see that, okay, we're exporting a variable and it's of type int and we're setting it equal to 40. Now, the other way you can do this is to remove int entirely and then just do colon equals. This will basically let the machine start reading from here, and as it reads across, it'll get to here and it'll go, okay, I want the type of this to be this value type. So this value type will be seen as an integer, set that as an integer. Personally, I prefer to just preset it like so. That just makes me feel more comfortable and more happy, and it makes things easier to read. Now for onReadies, what you'll see me do is use the as keyword. As is known as typecasting. So typesetting is going, this is the type that this thing is, whereas typecasting is saying, this is the thing I expect this variable to be. So if I typecast this as a int, I'm saying I'm expecting the value of this and this specific variable to be an integer. Whereas if I typecast this as a vector 2, I'm now saying I'm expecting this to be a vector 2. But as you can see, cannot cast a value of type int as vector 2 because it's seeing this and it's going, this is an integer, but it wants to be a vector 2. That's not how that works. It's just one of those little things to keep in mind. Now, why do we use typecasting? Typecasting is really useful for, actually, can I go one further? I might be able to just set this as a float as well, without the floating point number, but it will be able to be kind of adjusted and stored as a float, which is also interesting. Now, why do I use as for this? Well, typecasting for me, when it comes to setting up onReady variables or specific types of exported variables, and I say specific type, we'll kind of cover that at some point, it allows me to get IntelliSense or autocorrect. So you'll notice that if I go down into my function here, and then I start writing my, all of these variables that I've created are starting to pop up in the code completion or IntelliSense. It's telling me, okay, my array exists, my dictionary exists, and kind of so on and so forth. I like to make sure that I can get that anywhere. And sometimes you may need to just typecast something as the thing that you know it is. So the kind of machine can expect and use that IntelliSense. So you know, if I had a what's known as a specific class, I would typecast it as that, and then it might, well, it usually does give me IntelliSense on, or autocorrect, on the functionalities inside of that class. Now that's a whole other thing. Classes are a whole other thing that we will definitely be getting into. They're very, very important, and there are some do's and don'ts with them that can be get a bit messy. But that is, for variables specifically, pretty much all we need to cover for now. One other thing, actually, is you can do a thing known as exporting a category. So if I go export category, you'll see me use these quite often for editor readability. I will then add a name inside of this using a string value. So I will export this category as my variables. Then I'm going to hit Control S and save, go to scene, and you'll see here that there is a new menu at the very top here called My Variables, and it's showing my exported variable. Now, I'm going to set up another exported variable. I'm going to call this my underscore second underscore variable. We'll set this equal to a string value using that new typesetting method, so string, and I'm going to set this equal to, I don't know, let's go coffee. Love me some coffee. Hit Control S and save. Now I'm going to export another category above that, so export category. We'll call this my coffee don't touch. Get very defensive of my coffee sometimes. Then hit Control S and save. And you'll see, once again, it's reflected in the editor, but it's separating these variables now. Which means if I copy this currently exported variable and paste it a couple of times under, and then I'm going to add _2 and then _3 to these, and then hit Control S and save. You'll notice in the editor over here, these categories are still staying the same. So the category break, or the point where it stops, is when you create a new category. This will be very, very, very useful for being able to scroll to your editor quite a bit, and this is something that I don't see talked about enough, and we will definitely be using it a lot. Now I'm going to hit Control S and save. I'm going to scroll all the way down, and we're going to be looking at the same thing for, or the same type of typesetting for functions. Now, for functions have a thing as known as a return mode or a return variable, meaning if I go into my function and I type return, what this is going to do is it's going to run the function, and as soon as it gets here, it's going to stop, which means any code after this, so let's say my equation is equal to my int minus my underscore float, then I hit Control S and save, you'll see here that I'm getting a new error, a little warning that popped up. So if I go down into the debugger and I go to errors, it'll tell me here, unreachable code, statement after return in my function. If I click on that, it'll highlight the line. Now, what that's saying is because of this return word here, it's going to run this, and no matter what happens, it's going to hit this and then stop running the function. This is the, I want you to stop and return whatever result possible. Now, what is it returning is the question. Well, right now it's returning nothing. How do we make sure that the function knows that it shouldn't return anything? Well, as we're designing functions, what we're usually going to do is we'll do, in this case, my underscore function, and then we'll add parentheses. And then just after that, we'll add a line and then an arrow. What that says is, I want you to return this specific type. In this case, I'm going to write void. Void means I don't want you to return anything, which means this will work fine. But on the other chances that we want it to return something, which quite often we do, we'll go, I want you to return, let's say a float. And you'll see here, cannot return value of null because the function return is float, which means we now need to make this return a float. How do we do that? Well, just after the word return, we can press space and then type in whatever float or floating value we want it to be. So in this case, I would like this to return my equation. I'm going to get rid of this warning here so we don't have that yellow warning anymore. So with it returning my equation, what can we actually kind of do with this? Well, let's remove this print statement. Let's go into myReady, or the ready function, and then let's type print. And then what we're going to print is a string, and we'll call this my equation. I'm not spelling equation correctly. That looks right to me, it might be wrong. We'll do my equation, and then we'll put a space at the end here, then we'll add space, plus, and we'll use what's known as a string conversion. Why? Because a string conversion tends to be necessary when you want to add a string together with something. To do that, we just write str. So str is string, then we'll open parentheses, because this is another function. And now what we have to do is actually paste in or type in my underscore function. Now, what is this actually going to do? Before I show you, kind of pause the video for a second and just take a think about it, write down what you think it's going to do, and then I'll explain it. So what this is actually going to do is it's going to take whatever the return value is of my function, and it's going to turn it into a string, and then it's going to attach it to this print statement. So what's the value that it's returning? Well, it's returning my equation. What is my equation? It's equal to my int times my float. Okay, so if I hit the reload button here to get it to run again, you'll see in the bottom now, in the outputter, we have my equation, colon, 105. That is telling me that my equation is equal to 105. Now, let's say I change these numbers a little bit. Let's change my int to 42 and my float to 14.8. Hit Control S to save, run the current scene, and my equation is equal to 621.6. Now, let's go even further with this and apply some of the knowledge that we've already used. Let's export a new category. We'll call this my calculator. And now we're going to export these variables. So at export, I'm making all sorts of typing mistakes today. And then we'll do the same here with at export. I'm going to typecast these as their own individual thing, or typeset these as their own individual things again. So this is an integer. And then my float, of course, is a float. Control S to save. Go to my test scene. You'll see here we now have a new grouping called my calculator, and under here we have the int and the float. So let's put this into action. Let's run the scene again, see the equation's kind of final value, which is 621.6. Now let's change these in the editor specifically. Let's change this to 11 and this to 7.4. So let's get pretty much half of what we've been doing and run it again, 81.4. So as you can kind of see, this is how we end up using a lot of different types of variables. I apologize if this is a little bit complicated or the explanation is a bit rough. It can be a bit difficult to explain all of this in a short period of time. And as I said before, I will make an entire multi-episode long, full in-depth guide to GDScript and learning the language if that's something you'd like to see. But that is pretty much the entire process from kind of start to finish on what we need to keep in mind when we are going to be coding. And I will be going through the code with you and showing you what to do, and I'll be explaining each line of code individually and why we do certain things. Now, with that out of the way, we can actually start moving into making our little prototype. We'll also go over why prototyping is so important to the game process, or the game dev process. It is one of the best things ever. Anyway, for now though, I'm going to have to kind of leave you for the next video. So make sure you have a great game dev journey, and I will see you then.